Jai Hind all. I am Dr. Archita Bhatnagar, Associate Professor, CS Department, Faculty of Engineering and Technology, SBSU. Today we will be discussing about the a priori algorithm and the statistical measures in larger databases. So the a priori algorithm, it is related to the association rule mining when we talk about any particular data which is scattered here and there. If we want to know that what kind of data has what frequency and which data has the most frequency, then a priori algorithm gives us this view. Association rule describes that how one or more objects are related with each other. Generally, we apply this algorithm, a priori algorithm, on the database which consists huge amount of data and the huge number of transactions are there. Like the scenario is, for example, there is a big bazaar in which we are, in this example, we are taking example of 4 products, that is rice, pulse, oil and milk, and these are the number of transactions which are there for these particular products. For example, in transaction 1, rice is taken, pulse is taken, oil is taken, milk is not taken. In transaction 2, pulse, oil and milk are taken and rice is not taken. Means in transaction 2, rice is missing. In transaction 3, only milk is included. In transaction 4, rice, pulse and milk. Transaction 5 gives rice, pulse and oil. And transaction 6, every product is included. So how we apply a priori algorithm on this particular scenario? Step 1, we make a frequency table, that how many times all the products were taken. Like rice is taken how many times? 1, 2, 3, 4. So the frequency of rice is 4. Pulse is taken 5 times. The frequency of pulse is 5. Oil is taken 4 times and milk is taken 3 times. So the frequency of oil is 4 and likewise for milk it is 3. So we have made a frequency table, that rice 4, pulse 5 times, oil 4 times and milk 4 times. Now the step 2, we make pair of the products. For example, rice pulse, rice oil, rice milk, then pulse milk and oil milk. Only the combinations, means the pair of the products are made. So how many times those pairs are taken? Rice and pulse means in one transaction, rice and pulse how many times? 4. I'll just show you this thing. Rice and pulse how many times are taken with each other? Means rice pulse 1 1. 1 time, this 1 1, 2 time, this 3 times and this 4 times. So the combination of rice and pulse means RP is taken 4 times. Similarly, RO how many times? 1, 2 and 3. So likewise we make the table. So in this step 2, we are making the table for the frequency of the pair of products. RP is 4, like I told in the previous table. RP has 4 times, means frequency is 4. RO has frequency 3. RM 2, PO 4, PM, that is pulse and milk 3 times and oil and milk 2 times are taken together. This was the step 2. We are making pair of products and we are making a frequency table of those products which are taken together, means how many times those products are taken together. Then in this step 3, we find out that how many products are being taken, means more than 50%, like 3. So 3 or more frequency. What are the products with 3 or more frequency? This is 4, more than 3. RP, RO, PO and PM. So what we are excluding from this? We are excluding RM, rice and milk, and oil and milk, because the frequency is minimum, means less than 50%. 50%, more than 50% is 3 and more, 3 and 4, or if there was 5 from there. So we had to include those only. So we exclude the frequency 2. Now we have, with this table we have RP, RO, PO and PM. Now the step 4, we make a combination of 3 products from all these. So R, P, O and P, O, M. These are the combinations of 3. In the step 2, we made combination of 2, means we made pairs. Now we have to make, from that pair, we excluded 2 pairs. Now we have to make a group of 3 and we get 2 groups. First is RPO and second one is POM. Now we will see the frequency, that how many times this RPO is taken together and how many times this POM is taken together. So we will go to the first table and we find out that how many times this RPO is taken and POM is taken together. RPO means rice, pulse, oil, and POM is pulse, oil and milk. So rice, pulse, oil 1, then this is missing, so we will not include this. This is missing, this is missing. RPO 2 times, RPO 3 times. So these are rice, pulse and oil are taken together in 3 transactions. And pulse, oil and milk, here this is missing, so we will not include this. All are 1. These are missing, this is missing, and our POM 2. So RPO has frequency 3 and POM has frequency 2. So we make again a frequency table in which RPO and POM are given frequencies, that is RPO 3, which we saw in the above table, and POM is 2. Now we can easily find out that how many products are taken most of the time with each other, means rice, pulse and oil are taken by the consumers or the customers in most of the transactions. So this is the answer of what we needed. The question, whenever you will solve any type of question using Apriori algorithm, the question will be that what is the frequency of different products. It can be like this, and it can be like this, that which product or which group of products has highest frequency in different transactions. So both you can calculate by using the above method. Means step 1, we make a frequency table of all the products. Step 2, we make the pairs and we make a frequency table. Step 3, we find out that how many pair of products are being taken more than 50% of chances, like if there is 4, 3, 2 or 1 or 0. So we include 4 and 3. If it means we are excluding those pair of products which have frequency less than 50%. Then in step 4, we make include those pairs which are having 50% more than 50% frequency, and then we make trio of them. We make a group of 3, and then again we make a frequency table and we find out what is the group of product which is taken most of the times or most of the frequency is given. So this was the Apriori algorithm. Now we will see the statistical measures in larger databases. When we talk about statistics, we have the mathematical or the graphical version in our mind. So similar, we are correct in this also, at this point also. In database also, in larger database at the warehouse part, we have to find out the statistics from that particular data. We need to make certain statistics. So how we are making? Like in the relational databases, we use aggregate functions such as count, sum, average, max, min. So in this data warehouse or in the larger databases, we do not use these functions. We can use, but ideally we do not use. So what should we use? We have three things to be done in data warehouse, that is central tendency to be measured, dispersion of data to be measured, and to display this data graphically. So first we will discuss measures of central tendency. Central tendency means mean, mode and median. Everybody knows in the arithmetic classes we used to talk about mean of that data, median, mode. So here also we will go through this mean, mode and median. So first we will discuss about the mean. Means are of two types, simple arithmetic mean and weighted arithmetic mean. Simple arithmetic mean, we all know that the sum of all data divided by number of data. Okay, so this gives us the arithmetic mean, simple arithmetic mean. And if we talk about the weighted arithmetic mean, in this we will be given with the weights. So sum of weight multiplied by particular data divided by sum of weights, means this multiplication, sum of all the, means if we are given with the table, first data, its weight is this. So we multiply that data and we take all these data, the sum of every data is weight and particular data, and divided by sum of only single weights without multiplying with the data. So this is how we find out the weighted arithmetic mean. Then median, there are two cases in which median can be there. If we have number of data odd, then the formula is n plus 1th term by 2. Okay, and for example, if we have this data 1, 4, 6, 7, 12, 14, 18. Number of data is 1, 2, 3, 4, 5, 6, 7. 7 is odd. So we put this formula. So we have n plus 1th term means 7 plus 1th term means 8th. 7 plus 1 is 8. 8th term by 2, 4th. 4th term is 1, 2, 3, 4. So the median is 7. But the case if the number of data is even, if it is even, then our formula is nth term by 2. For example, 1, 4, 6, 7, 8, 12, 14, 16. This is the data. How many data is what is the number? 1, 2, 3, 4, 5, 6, 7, 8. 8 is even. So we put this formula. 8 by 2 is 4. 1, 2, 3, 4. So median is 7. Now mode. Mode defines that how many times a particular number is repeated in any particular data. So that is mode. If the number, every number is used single times, then it will be unimodal. If any number is used 2 times, it will be bimodal, and if it is more than 2 times, then it will be multimodal. Then second is measuring the dispersion of data. This was measuring the central tendency. Now we will discuss about the dispersion of data. So in dispersion of data, we talk about the range and the quartiles and standard deviation. So range is largest value minus smallest value. It gives us the range. So it is representing the data between the largest value and the smallest value. Quartiles give us 25%, 50% and 75%. So 2 quartiles are there, 25%, 75% and interquartile is 50%. So we divide our data into 4 parts, that is 0 to 25, 25 to 50, 50 to 75 and 75 to 100. So these are the quartiles. First quartile 25%, second quartile 75% and interquartile 50%. So interquartile, the formula gives Q3 minus Q1. And the standard deviation, it is the formula in which the population we have to find out. This is the standard deviation population, and each value from the population minus the population mean, it is squared, and we take the aggregation of that data divided by the size of population, and then we take the square root. So this is the whole formula of standard deviation. So this is how we find out the dispersion of data. And lastly, the graphical display. Everybody knows that if we want to give a graphical display of any data, we can use histograms. These are the parallel bars. Now the quartile plots, in which the 25%, 75% interquartile, these are mentioned in the plots, in the graph. Q to Q plot means if we are talking about two different data, there will be different quartiles defined. Scatter plot, whatever the data is, we just plot it over there. We do not give any of the diagrammatic decomposition. And lossless plot, in this we are making a plot in which there will be no loss. So this was all about the a priori algorithm and the statistics which are included in the data. Jai Hind.